Unit 10, Day 4, Homework Tutorial. This homework tutorial might seem a little lengthy because I'm going to show you how to access the online textbook as well. I put the information on my webpage. As you can see, I'm on my webpage right now. And if you want to access the online textbook, you can type in the website that I gave you. If you forgot what that was, you can click here for directions. And then it tells you which website, the web address, and it also tells you how to log in. When you log in, you're going to use your student email address as your username, and your password will be your first initial, your last initial, both of them lowercase, and your student ID number. From this set of directions, you can click the web page and it'll take you right there. So when I log in as myself, I'm using my email address. However, yours looks slightly different. And as soon as you log in, depending on how many textbooks are under your name, you'll see them listed. As I have two, I can see the student edition or the teacher edition. Doesn't matter which one I click. And then you would go to ebook. And that's how you access the textbook online. And then again, we're in chapter 10 right now, so you should come to the table of contents, click chapter 10, and this homework assignment is coming from lesson 5, which is tangents, and it starts on page 735. So let's go there. If you want to zoom in, that's how you zoom in. Get the green one. All right. So your homework assignment is 2 through 6, 13 through 22, 24, and 25. And this tutorial will help assist you with the even problems because the odd problems you already have the answers in the back. So on number 2, it wants us to determine whether FG is a tangent to circle E. So to do that, when we went over the notes, I told you you had to prove Pythagorean's theorem. Pythagorean's theorem, for those who have forgotten, is a squared plus b squared equals c squared. So the right angle is assumed to be here. Across from the right angle is always c, so that means c is 12. And then a and b are 6 and 10. So 6 squared plus 10 squared. And then 6 squared is 36. 10 squared is 100. 12 squared is 144. Add up 36 with 100, you would get 136 is equal to 144. That is false. So we did not prove Pythagorean's theorem. And because we did not prove Pythagorean's theorem, we would have to say no, FG is not tangent to circle E. So for number 4, it wants us to find x. And it says assume that segments that appear to be tangent are tangent. So that means MN appears to be tangent. So if MN is tangent, there's a right angle right here. So we could find x by using Pythagorean's theorem. Again, that's a squared plus b squared equals c squared. So c would be x this time. And then 16 and 12 are a and b. 16 squared, I believe is, I'm not even going to lie to you, I forgot. 256. 12 squared is 144. Combine 256 with 144, you would have 300 equals x squared. And then we must take the square root of both sides to get x completely isolated. So let's use our calculator to find the square root of 300. It's roughly 17.3. I'm sorry, it's 400. 256. Let me just double check to be on the safe side. My brain is not functioning 100% right now. Yeah, 400. So I would need the square root of 400, which is 20. So x is 20. On number 6, we're going to use theorem 10.11, which stated that if two tangent lines are intersect at the same point, those two tangent lines are congruent. So that means this tangent line 3x is congruent with this one 5x minus 8. So since they're congruent, the measurements are equal. So I can say 5x minus 8 equals 3x to solve for x. I would subtract 5x, which would leave me with negative 8 is equal to negative 2x, and then divide by negative 2 on both sides, and 4 is equal to x. On to number 14. Is very similar to number 2. We got to prove Pythagorean's theorem. So again, a squared plus b squared equals c squared. So we're trying to prove if xy is the tangent, so that means there would be a right angle here. C is not shown in its entirety on the diagram. It only shows you a portion of C, the outside portion, which is 4. The other portion, this piece here, is a radius of the circle, and it's showing below that zy represents a radius. So that means there's a 6 right here. So in total, it's 10. for zx, which is c. So c again is 10, and then a and b are 6 and 8. 6 squared is 36, 8 squared is 64, and 10 squared is 100. Combine 36 with 64, you get 100. And yes, 100 does equal 100. So since I proved Pythagorean's theorem, I have proved that yes, xy is tangent to circle Z. All right, on number 16, same concept. Prove Pythagorean's theorem. C is the square root of 80. A and B are 4 and 8. 4 squared is 16. 8 squared is 64. And anytime you square a square root, they technically cancel each other out. You'll learn more about that in Algebra 2. But again, a square and a square root cancel each other out. So the right side is simply just 80. Now combine 16 and 64, you get 80 as well. So yes, 80 does equal 80. Thus, xy is tangent to circle Z. On 18, we're finding x, and we're going to use Pythagorean's theorem again. So a squared plus b squared equals c squared. And the tangent line would be VU. So the right angle would be here across from 11. So 11 is C, and 7 and X are A and B. 7 squared is 49. 11 squared is 121. Subtract 49 from both sides. You would have x squared is equal to 72. And you must take the square root of both sides to get x by itself. And the square root of 72 8.5, since it wants us to round to the nearest tenth, so 8.5. On number 20, same idea. Prove Pythagorean's theorem. A squared plus b squared equals c squared. So the right angle would be here right at S. So C this time is x plus 12, because you have to combine both of these parts. RS is x. So A would be x, B would be 20, and C would be x plus 12. So that would be x squared plus 400 is equal to. Now again in class, when it comes to multiplying x plus 12 by itself, I trained you to use the box, or you can use the FOIL method, whichever you're most comfortable with, but I recommend the box. Put your x plus 12 at the top and x plus 12 down the side, and multiply part for part. So x times x is x squared. X times 12 is 12x. And it'll be the same thing here. And then 12 times 12 is 144. So when you pull the results out the box, you would have x squared plus 12x plus 12x, so that's plus 24x, and then plus 144. All right, and now we want to get our x squareds to the same side. So you subtract them. In doing so, they cancel each other out, leaving only 400 on the left, 24x plus 144 on the right. So now you subtract 144, and you would get 256 equals 24x. And then, sorry, my feet are falling asleep. Divide both sides by 24. And you get roughly 10.7. On 22, we're going to use 10, 11. Oh, anytime we use Pythagorean's theorem, we're using 10, 10, just FYI. And for 10, 11, it tells us that, again, if two tangent lines intersect at the same point, that they're congruent. So in this one, FE is congruent with DE. So that means 2x equals 6x minus 4. So subtract 6x, you get negative 4x equals negative 4. Divide by negative 4 on both sides. X is equal to 1. 10, 11 is pretty easy. Requires less steps, that is. And the last homework problem, number 24. Number 24 wants you first to find the value of x, and then find the perimeter of the outermost figure. So this is on 24, you see 3 sets of theorem 10, 11. There's one right here. There's a pair of congruent segments. Here's a pair of congruent segments. Oh my gosh. And here's the third pair of congruent segments. So, keeping that in mind, that means 14 is equal to 2x because it's the yellow portions that are highlighted. So this would help me find x divided by 2. So that means 7 is equal to x. So that means this is 14. And if that is 14, this portion would be 17. If the whole entire thing is 27, that means this green part is 10 and the other green part is 10. Now to find the perimeter, we add up all of the sides. So that would be 10 plus 10 plus 17 plus 17 plus 14 plus 14. We know 10 plus 10 is 20, so that's less typing to do. 17 plus 17 is 34. And 14 plus 14 is 28. And the total perimeter is 82. This concludes your tutorial for this assignment. I hope it was helpful.